Hey everyone, Jason here. Lesson 3 for sheet metal review, 308A C of Q. If you, again, like I said before, if you failed once or twice or even several times, or even if you just want a little refresher out of school before you go write the exam, you've come to the right place. Now let's get started. Okay. All right, guys. Throw in a safety question that just popped up. Somebody brought to me about scaffolding again. So here's another scaffolding one. That's a bit of a tricky one because it's an order of operations, and really. You're setting up scaffolding, you set it up, you level it, you think you're done, but no, they got to make it even more complicated. So what they do is they say, okay, you're going to erect the scaffolding, then you're going to level the scaffolding, then they're going to give you an option in these order of operations questions. What do you do first? So one of the options is to put on your PPE. Now what they're going to talk about is tying off, putting on your fall arrest or travel restraint. So basically, if you think about it, so there's basically one section of scaffolding and then the levelers on there, right? So here you're approximately 5-6 feet high. So now if you do a second section, put your cross braces on and then put your next set of planks on there, now you are going to be at least 10 feet high. So where they throw that in the order of operations is, do you put your PPE on after that's on, or after you put that together, or before you put it together? So it's a bit tricky. You got to make sure you read the answers and pay attention and actually think, because when you're actually done this and you've put the next plank on, or your planks on the top here, and you're ready to keep building, you are now at that height. So there, that you'll be at 10 feet. So yes, you should have your fall arrest on or tied up or some, because they say PPE. What are they talking about? Couldn't tell you. They could be talking about tying off, or are they talking about just putting guardrails on that to work? They're not specific, but this is where you got to pay attention to what you're doing. So build first section, level it, and then continue on. And watch out for putting on your PPE. Just wanted to go over that one. Okay, thanks. Just want to. Oh, and again, a couple of little safety. It's like a safety, or it's a miscellaneous type of safety, or how to do certain things. Is using a chop saw. So there's your blade for a chop saw, and where the vise where you clamp stuff in. Possible question is cutting angle iron, and that's where it should be. It should be up that way. It should not be that direction. It should not be that direction, and it definitely shouldn't be away from the center. That's where it should be. Okay, just. It's pretty. I've seen people do strange things with chop saws, so just want to make sure that everybody's on the same page on how to use a chop saw. Same thing with cutting a piece of metal or wood or whatever you're cutting. There it is. Oops. There it is on your sawhorse. If you were to cut that, where would you cut it? Like most of us know that basically that should be your cut line. So when your piece cuts, it falls away. Should you cut it there? Definitely not, because it's going to bind. Just making sure. These are kind of little safety questions that are known to pop up on the CFQ, and I've seen people not understand how to answer that question. So I just wanted to go over that and make sure everyone's aware of it. All right. This is lesson 3. lesson 2 dragged on for quite some time. If you're following this up immediately, you're like, wow, that was lesson 1 was just over an hour. Lesson 2 was right over 2 hours. But we went over a lot of stuff, a lot of math, and I was trying to bring you up to date with just reviewing basic pattern with just the simple stuff. But hopefully, you know, we'll keep going over it. Every lesson that I do, I'm going to try to go over the important stuff, especially the stuff that's hard to memorize and stuff, but we'll just review it every lesson. But this lesson, we're going to continue with a little bit of math, but we're going to start with just Pythagoras again. I know I touched on a bit of Pythagoras last time, but again, this is where you guys have to be able to recognize what's coming at you in a question. It's your detective work, so to say. What if here's a possible question, and a lot of guys get really confused by this. There is profile of eavestrough, right? So again, they're going to ask you for the stretch out, and right away they love to use the word stretch out. Now, in pattern drafting, you should know what that is. Basically, when you stretch that out, it's a flat piece of metal stretched out, right? How much material is used in here? Okay, 1/2 inch. I say from there to there is 3. From there to there is 3. I'll say from here to here is 5. And I'll say from there to there is 5. So, you know, 1/2 inch, 1/2 inch, 3 inches, 3 inches, 5 inches. But of course, they leave out this little piece right here. And of course, everyone's looking at that going, well, if that's 2, that's fine. Right away, your brain should be clicking in, oh, this is Pythagoras. This is where, like I say, again, your detective work. Right away, you see a question, oh, there's an imaginary triangle there. If that's 5 inches and that's 3 inches, right away, you know that's 2, and you know that's 2. Of course, some guys don't click into this right away because a lot of guys don't read drawings, which drives me crazy. You're in construction, you should be reading shop drawings. You should be reading installation manuals. You should be reading architectural drawings. You should be reading mechanical drawings, ID drawings. And if you're not reading those on job sites as an apprentice, it means either you don't care and you just couldn't be bothered, or maybe somebody's not making that available to you, which is a shame. So I'm just going to look into my thing here, and hopefully you guys can see that. Maybe zoom in a little bit more just for a little bit better. Look at that. So again, we got 5 inches plus 3 and 3. I'll just call that 6. 1/2 and 1/2. 1. And then, of course, you've got Pythagoras here. 2 squared plus 2 squared. Pretty straightforward. Do I have to go through the math with you? I don't think so. But excuse me, that's basically it there. And again, trying not to get played by that on the CFQ, because again, you have to be able to think for yourself. You can't have, and you won't have, somebody that's spoon feeding you these questions. You have to be, have, again, firm grasp with the material and be able to think what you're going to do and how to attack these questions on your own. Let's go on to another one where you're going to have to know that you're talking about Pythagoras. They could give you a transition like this. Now, this one's easier. If I tell you that's 20 by 12, and I tell you that this is 16 by 12, well, it's flat on bottom and flat on top, but you do have that kick right there. So again, there you are. You got it. You have to triangulate that. You have to use Pythagoras. So again, if that's 20 and that's 16, you have 4 inches there. And if I tell you that this is 12 inches long, you know that's 12. I'm not going to get into the finer parts of this, you know, if you got allowances there and stuff. We're just going to do the basic net from that. So again, Pythagoras, and again, you should always be writing down your formula, whether you go. I like to see that. All the guys I tutor, I tell them to show your work. It's good practice. So a squared plus b squared. So we can call it 4 squared plus 12 squared, and then you square root it. And again, I'm not going to go through the math because you guys should already be good enough that you don't need to practice this with me here right now. That's just going to eat up more of your time. But again, spotting that. Now, here's another one with this. I'm going to change this a bit. I'm going to make this 16 by 10. Now, somebody might say, okay, you got to triangulate that side piece right there. Oh, but I'm going to make this flat on bottom. So what does that mean? Well, most of you guys should know, if you're sheet metal workers, even if you're not a shop guy, but you also should know that you have to triangulate that top piece now. Because if I give you a side view of it, excuse me, I say flat on bottom. So basically this side would be 12 by 20, and this side would be 10 by 16, right? Just to make it look a little bit more, you can just tell there's your 3D look. That's looking at that fitting from the side. So with this piece coming down like that, it's going to be a little bit longer than that one. So yeah, you need to triangulate it. There's your little triangle. How much? 2 inches by however long this is to make it 12 inches long. And it won't be much, but it's an important thing. But no one's going to tell you that. No one's going to say, oh, this needs to be triangulated. You need to do Pythagoras to figure out the proper length of that. It's just, they tell you by showing you those 2 measurements. And you have to triangulate that. And how will it be thrown at you? That question can be thrown at you many different ways. But again, there's Pythagoras. Now, what other possibilities are here? Okay. Here's another one I love. That people, when you look at that, and again, it's the same thing. That's your side view of a fitting, but they're just going to go like this. They're going to say that this is 10. They'll say that that's 6. And that's 20. What is X? And like, how many people look at that and they're just deer in headlights. So basically, again, there's your triangle. If that's 10 and that's 6, well, that's pretty obvious. That's 4. And the 20 is right there. So 4 squared. 20 squared, square rooted, done. All right, so it's not that difficult, but what gets difficult is you trying to recognize it. Now with the one we just did, I'm gonna show you the one that's really complicated, that really messes with people. So. $100 by 300. So, and again, they want X. Now, when you get this question, because of, let's see if that looks, how blurry that looks. I'm sure you can see that's 100, right? So, when you see that question, there's so many numbers on there that it can be kind of confusing. So when you read 100 by 300, the side that you're looking at is always the first number. So that tells me that 100 is that number. So what's the 300? Well, if I put another line on there to make that look three-dimensional, that 300 is right there. That 300 is right there. So again, 100, 225. What's left over? 125. So 125 squared, 275 squared, square rooted. Pythagoras. And that is one of your more difficult ones that people have trouble understanding. Hopefully I didn't rub that out too fast for you. You can always press pause. That's what's great about this. So here's another Pythagoras question. Now again, what they talk about, the way they word questions on the C of Q, I always talk about reading and comprehension. So here's the type of question that you could get, where they don't draw you a picture. Like, I'm drawing you pictures of all this stuff, but they don't always draw you the picture because it makes it really easy sometimes. So imagine this. They're going to tell you you have a B vent. Let's just do it like this. B vent. 9 feet high. And you're going to secure it with 3 cables to pitch pockets. And I know, like most guys, a lot of people say, what is a pitch pocket? Doesn't matter. It's just, you know, use these fancy words to confuse people. So they using 3 separate cables that you're going to secure this B vent to pitch pockets in the roof that are 4 feet away from the B vent. Okay, so again, well, now we got to put a picture to that. So there's your roof. Now a B vent's pretty self-explanatory. We'll even get into that in the next bit right now, because I'm going to start talking about some flashings and stuff like that for the roof. There's your B vent. We'll say it's 9 feet high. And then the cable in the pinch pocket down here, or whatever that is 4 feet away. Now, would you have been able to figure out that they were talking about Pythagoras, right? 9 feet high, 4 feet away, there's your triangle. So again, 9 squared plus 4 squared, square rooted, right? Again, would you have been able to read that question and put that together, that they were looking for a Pythagoras? The only thing that would have been good, that you should keep your mind and your eyes open to, is looking at the answer column, A, B, C, and D. Read what the possible answers are, because the clues are there too, right? Like, again, most of the answers in that would have been all lengths, because that's what we're looking for, is obviously a length. How much cable is needed to do that secure? Now, of course, once you've got this answer, times 3, because they also say 3 cables too. So, you know, another estimated question. I don't know if I went over that already, but I might have. But again, it's Pythagoras. And we'll move on, because again, I'm just trying to get you aware of what's possibly coming at you when it comes to Pythagoras. Here's another one where they're looking for the estimation of metal for an open chute. So again, they don't draw the chute. But I see people, I see schools, because again, I get lots of school work from all the different trade schools in and around Toronto, and I'll see this question. But I think what they don't go over with people is when they give this question, it's not drawn out. If any of you guys have ever gone to the Red Seal website for the 308A, they have 20 practice questions on there. And actually, they got some pretty complicated practice questions on there, which are good for getting you back into your math. But again, they talk about an open chute that's like that. But they don't show you a picture of it. What they say is that open chute has a vertical height, which is that of say 10 feet. I'm just going to use that. And then they're going to say that you have a horizontal distance. Again, I'll just use 10 feet. Again, like that. So, and there's your open chute. Again, if they don't draw you a picture, it makes it pretty difficult. That you've got to use your brain and envision this as well, right? So again, 10, 10, so it's going to be 10 squared plus 10 squared, square rooted, and then you'll get that length. All right, so just, well, I'm not going to spend a whole lot of time with it. I just wanted to get that back into your brain. So, because again, you guys are going to start hitting triangulation. There's that kind of triangulation, and again, if they're looking for measurements, because again, you got A, B, and C possible measurements. As when we get into the more complicated, the SOHCAHTOA, you're going to add angles into that. So that's where you oh, there's an angle. Okay, well that's not Pythagoras, right? Or there's no is there an angle or is there not an angle? Which is going to make it very important for you to recognize which kind of question or which kind of formula it is. So now we're going to do one more. This is a layout question. Let's, just to keep your head. So they give you this. Actually, what I'll do is, that's the side profile of a hood. And then here's the top of it. So again, that part right there is looking down, and the outside is that. So again, I'm going to tell you that that's 38, right, 38, and that's 10 inches, and that's 10 inches. Oh, and then I'm going to tell you that the height of that is 24. So using that to lay this out, you need to get that length. And of course, again, that's Pythagoras, right? So let's take a look at that. So if I break that down the center like that, like right there, so there's 10, right? So if I've got 38, so they just doing the math, I haven't done this question in a while. So even trying to think, half of 38 is 19, right? So from there to there is 19, knock off 5. So now really from there to there is 14. So if I take this triangle down here, I've got 14 at one side, and this is right there is 24. So 24 squared plus 14 squared, square rooted, is going to give me from there to there, give me X. Okay, and again, if you're having trouble with that, if you are having trouble with that, I hope you don't. I hope you can find somebody, because again, why am I doing this online like this? Because again, most guys around the GTA or Toronto area come to see me, they phone me, and I even help guys on the phone sometimes. But there's going to be guys that there's guys that live hours away from me, and that they don't have the help for this. So hopefully this is enough for most guys. But if not, I think at the end of the last lesson, I've put up my email. Okay, I had to stop that because for some reason it was flashing. I think I was coming at the end of my bit there. I put at the end of my last lesson my email address. If somebody's really struggling, especially at the end of this, because again, we're going to keep going over stuff, and if you're having trouble with this, and you're still struggling, well, email me. I help guys all the time. My phone rings all the time with things that guys don't understand, and like to take 2 minutes on the phone and explain something, or through an email, like, you know, take a picture of a formula and say this is where you're messing it up, and helping guys out like that. I don't mind. Like, am I going to sit on the phone with you for 3 hours? Not likely, but there's always some way of helping with this stuff. Okay, so I just did that last one. Now here's a great little shortcut that Pythagoras is used for, which teachers don't teach. Not any of the ones that I know. Somebody showed me this a while back, and it's for a Y branch. So there's your Y branch, terrible looking Y branch. So if I was to tell you the two small ends, if I told you that was 5 inches round and that was 5 inches round, and I asked you what the large end was, you could use Pythagoras for this. And I double checked this, and because the long way to do this would be find out the square area of that, find out the square area of that, and that would give you the square area. So again, it's an equal area transition. But to do this as a shortcut, you could use Pythagoras. So you would go 5 squared plus 5 squared, square root that, and that would give you that side. And it's interesting. It works so many different ways too. And I learned this from some other teacher years ago, because there's another possible question that used to pop up, that it would say, okay, you have a supply run going into a room. It has 2 8-inch round takeoffs and 3 6-inch round takeoffs. What's the round size of that supply run? And again, the way I was taught at Mohawk was to figure out the square area of each one of those takeoffs and combine them together to give you the square area of that supply run. But again, another teacher taught me a shortcut to that, using Pythagoras. If I was to do this, 8 squared plus 8 squared plus 6 plus 6 squared plus 6 squared, and square root that whole thing, it would tell me that my supply run coming into the room would be basically 16 inches round. And I'd have, like, and again, to picture that, right, supply runs coming into your room there, right? And again, that's using Pythagoras for a shortcut. And not that it would ever matter, but Pythagoras also works backwards as well. So if you had your triangle, or even if you had a Y branch, sorry, like that, there's your Y branch, ugly looking one. If I gave you this one, if I gave you, say, 30 inches, and I told you that was 20, using Pythagoras, like 8, instead of a squared, I go c squared minus b equals a squared, right? So, and then of course just square rooting it would give you that one. Same thing with that. Does a question ever come up like that? No. So I'm not even gonna really get into that, but again, I just wanted to show you that one with the Y branch because it's a great shortcut. Because that question used to pop up. Does it still pop up? I don't know. Basically, sometimes they just show it to you like that, like a Y branch, like that. You know, A, B, and C, right? So, we'll, you know, a little short jump back into Pythagoras there that I wanted to go over. Try not to use too much time with that. And I gotta go get a drink of water because my throat's killing me. Okay, I feel a little better now. Thanks for asking. Okay, we're just gonna go into other miscellaneous stuff, but before I go into roofing and flashings and stuff, I'm just going to go into something that I jotted down here is plasma. There's not too many possible things to go over with plasma. It's just going to be questions like, why do we use a plasma? Mainly because to save on labor costs. Labor costs and number of hours worked. First thing we do after the plasma is done, as we're taking the pieces off, we mark and or label, and if label the pieces, or you might as well just throw them into the garbage bin, because you'll never figure out what piece is what. How do you clean a plasma? Basically, a wire brush. What can't you use with the plasma? So, a question for, you're cutting painted corrugated roofing metal. Can you use, or what can't you use? Snips, a hole saw, a sawzall, or a plasma? And the answer is plasma, because it's painted. So this is like, again, those kind of questions are where you got to read and pay attention. Like, of course, it's painted metal. That you know, little clues like that they throw in there. And so here's one last question that has been people have asked me, that come to me with this question is, what's the first thing that goes into the plasma program? So basically, you pull up, say, the Vulkan program on your computer, and the program starts running. What's the first thing you're going to punch in? I've talked to several guys about this that actually do the Vulkan, and basically they agree that the possibilities on a question like this popping up is what fitting, what are you going to make, the dimensions, number of pieces, the gauge. Myself personally, when I did it in school, the first thing that popped up was one picture that had all the different fittings, and you would click on that fitting, right? But what makes sense to me, the first thing that you would do with it is name the job, theoretically. But is that answer going to be in the answer columns? And this is where you need to read all the possible answers and then make your decision. What is the best possible answer from that? And again, you're not going to talk about the gauge, because you can't talk about gauge until why do we pick gauge? Well, it would be the width of your one of your sides. Like, say, as simple as duct. If a duct is 24 inches wide as opposed to 10 inches wide, different duct size. There's the Smackner rule. Like most guys, when I go into guys' shops, and they have a list right there on the wall, and it'll show the gauges. And of course, well, like most most shops, even with a plasma, when it comes up at the end, it'll show the gauge, and it'll show Smackner's recommended gauge, and of course, everybody changes that, goes up a gauge just to save on weight or metal, which is, you know, terrible, but business is business, right? So again, what's the first thing you would put into the program when you're making using the plasma? I'm going to say either you're going to pick your fitting, type of fitting, or you're going to name the job. But again, please pay attention to what it's saying. And for now, unless something else pops up and I'm going through my notes to think about what else to go over with plasma, I'll save it for another time. So what I want to get into now is something that comes up on the C of Q, but only in small doses, are flashings. Flashings and anything other things related to the roof, like, you know, even B-vent coming through the roof, like china caps and stuff like that. So we'll go through all. I got a few pages of notes here that you know, are, as I say, they're things that are going to pop up, so you should know them. Not to mention, hey, not that we're roofers, but we are roofers because it's sheet metal. Anything to do with sheet metal. So one thing pops. This that pops up is lagging. Do you know what lagging is? So basically, say you're on the roof. There's your duct, and the specs call it for it to be insulated. So you wrap your duct with insulation. Then that insulation needs to be protected. That's lagging. So there's lots of different types of questions with lagging. The first one being is the order. This one pops up, order of operations. So if there's your profile of the duct, right? If you were gonna wrap this, and I've done it back in the day, they used to give you a roll of aluminum and that brake that the roofers use, drag it up on a roof and cut and put pieces around this. So basically, you would put a bottom piece on like this, and of course it's going to be tighter than that. This is just so you can understand. Then you're going to go sides. So right away you can see that has gone overlapping that so water can't get in there. And then your cap. And then you could possibly seal that, but even that, if bottom, sides, top, order of operations for lagging a piece of duct. So while we're still lagging a piece of duct, let's say it's round, even though you could do it with, so say there's your, say it's round, it doesn't matter if it's round, and there's your piece of insulation around it, then you what is your best option for securing that, or the proper wording for that is to mechanically fasten this. And options are, well, when I did this when I was younger, working for my dad, because he was cheap, here's a roll of string, tie it on, and hey, it works. It's mechanically fastening it. Is it the right way to do it? No, because that string would rot away in probably less than a year, maybe 2 years, and it would all fall off. So another one, stick pins. You know what? Hey, stick pins, tape and tape. There's another possibility. But the one possibility that, of course, your employer would never use would be stainless steel gear clamps, or even just a galvanized gear clamp, because wow, would that be expensive. But guess what? Cost is not going to come into play on the CFQ, or when it does come into play, choose cost. Because if you go A, B, C, and D, and string was there, of course, most bosses would say yes, string. Pins are good. Pins, and then you pin it. There's nothing wrong with that. But a stainless steel or even a galvanized gear clamp every couple of feet is the best thing that you could do. And you got to remember, when you're answering questions on CFQ, never put cost as a lesser option. Cost is always the better option. If it costs more, and you're like, oh, my boss would never allow that, that's the answer. Believe me. It always comes in. Okay, simple stuff, right? And again, I wrote the CFQ. This is 2018 right now. I wrote approximately 9, 10, maybe something like 10 years ago, say. And the CFQ is evolving. It changes. Mainly, they want to make it more difficult or just change it because, again, I've been doing this for 10 years now, and everybody I talk to that comes from different schools, and this person, that person, oh, they see cheat sheets. All right, show me your cheat sheets. And right away, I can look at a set of cheat sheets and say, well, yeah, probably about 5% of those answers are any good. And because basically, then why have a test, right? And I'm sure that's what the ministry is thinking, or the College of Trade, is why bother having the same test for 20 years? Because basically someone's going to have it memorized, whether somebody stole the test, or it needs to keep evolving, especially evolving with the trade as it changes. That's why new plasma questions are coming in and stuff like that. So one thing they seem to love are order of operations questions. So yeah, you might know what the question is, but or a straight answer. And here's a perfect example of one. So I'm going to show you roof line. That's your chimney. The flashing that goes behind the chimney. And if you went to school or you're a roofer, you know it's a cricket or a saddle. That used to always be a question on the CFQ. Well, it still might pop up, but now they've made it a little bit more difficult. Now they ask for the order of operations for that. And unless you've actually installed this stuff or somebody taught it to you at school, you're not going to really know. But basically, with roofing, you basically most of the time you start from the bottom and work upwards for to repel water. So basically, your first step one would be your base. So that's one. Step two are the sides, also known as steps. And you know, when you actually look at it, somebody explains it to you, because you gotta remember, most chimneys are like, it's all brick, right? So that's what the idea of the steps. So you'd have it like that. Like that. And the original, like the way they used to do it back in the day was, now why are they stepped like that? Because that flashing is following the mortar joints. And it's actually embedded in the mortar joints. Do you think bricklayers and roofers actually bother with that anymore? No, they actually do a really shit job. Excuse my French. So basically, they just put some tar there and they just nail pin it. Which, back in the day, when they used to do it properly, was leave the mortar joints open and use a little fancy thing called a reglet. Something that looked like that. And that would be put into your mortar joint, shoved in, and then mortared over. And that would last a lifetime. It would last not 10 years or 20 years. That thing would last 100 years. Because I've done, when I've gone up and checked flashings on roofs, helping buddies out, try to go to rip that out, you need a crowbar to rip it out of there. It's near impossible. But anyways, so there's your steps. And then 3 is your cricket or your saddle that goes right there. So then the last part of that is you're going to seal it, because basically it also needs to be sealed there as well. So we'll just put cricket or saddle, and the number 4 is to seal it. Oh, and there's another little quick tidbit with questions. If it's order of operations, I may have already gone over this, but I'm going to go over it again for thinking time. If you have to fabricate something, what's the first thing you're going to do? You're most likely going to measure it. So when you're doing order of operations and you look at the 4 possible answers, if measure is the 3rd or 4th thing, obviously it's not right. Now, will they do that? Yeah, possibly. Same thing with when you seal something. You never seal something 2nd or 3rd. It's always last. So, as I say, using your detective work, when you look through the answers, oh, seal is the 3rd thing, or measure is the 2nd or 3rd thing. It's like, it can't be, unless there's something even more obvious in front of those answers. So, again, it comes down to thinking. So, there's that one. And we're gonna go over a few of these things, because again, these kind of questions pop up. And of course, unless you're a roofer, hey, most guys taking the sheet metal exam, the 308A, are not roofers. Some of them are, but most of us hang duct for a living, right? So when it comes to even the order of operations for breaking an eaves trough, so like they say, like that eaves trough that I showed you earlier, what would be the order of operations? The smallest to largest, right? So again, those are the two smallest bends. These are the two biggest bends, right? They're the easiest ones, right? So again, they would go like 1, 2, 3, 4, or 1, 2, 3, 4. I think just remember smallest to largest, right? Just to make it easier on yourself. But and that again, order of operations still comes up. So another one. We're gonna get into depth with this one because this one comes up a lot. We're gonna talk about a parapet wall. Now this could be just any wall on a roof of a building. You know, when it, like the facade of a building comes up and you see the brick at the front, but if you actually go up at the top of it, the roof is actually below that. The roof is down here somewhere, and that would be the front of your building here. So. First simple question, how do you protect this wall from getting wet? With a coping, or what's known as a cap flashing. And that's just a generalization, and you know, put a drip edge on it, right? Sorry, it's not the prettiest drawing. But that used to be as simple as it was over the last 10 years with CFQ. Something nice and simple like that. But now, it's getting a little bit more difficult. Now they're going to ask you for an order of operations question with this. So, what else is there to this? Well, there's also, let's see if I can do it by hand, or should I get a ruler out just to kind of right in behind that is your, let me name this. Cap or coping. Cap flashing or coping. And then what's going on right here, because that's going to cap that piece, and that's going to be, as it comes down here, is your counter flashing. Now, I've read a lot of material on the naming of stuff like this. So as this comes down here, you're going to have that little piece down there, and that's called your cant strip. Right? And then that's going to go down there, and then of course you're going to have your roofing material there. So the idea is to keep it all from getting inside this wall. So down here, and of course I want to draw it because I'm going to actually pause for a second. Alright, perfect. So, because again, I'm not a roofer. I just wanted to double check my stuff here because again, so as this comes down, that's your flashing. And then as it comes down here, and as all this comes together down here, this hooks up with a piece right here with a drip edge on it, and this piece right here is your counter flashing. Because a possible question that pops up is, how do you protect the base of a parapet wall that's counter flashing? Because again, the old question was, how do you protect the top? How do you protect the top of the wall or the wall? It's a cap flashing or a counter flashing. How do you protect the bottom of the wall? The counter flashing, right? Because that's just a straight piece of metal. This is a little side bent or piece to come out over the can strip, and with a little drip edge. Because then the roofing material is going to come up underneath that, right? And then there's the order of operations. Now this is a tricky one. And as far as I'm concerned, it's not even a fair question, because I talk to roofers on job sites all the time. And I ask them about the order of operations, and even they're confused with the possible answers for this. So, possible answers for order of operations for a coping are, let me see if I got room on the board here. I'm going to slide over here. Yeah. So, basically, you have cap, flashing, seal, and of course, caulker seal. That will be your last one. But they also have something called a corner. And again, I'm trying to figure out, talking to the roofers, what's the corner? Well, if you're looking down from the plan view, because that's an elevation or side view. So if you're looking at the top of a roof, and there's the parapet wall, right? There's the roof with all the gravel on it, or soon to be gravel. So as you put that flashing on top there, and you put that flashing there, you have a corner right here. And if you think about it, you start thinking about all those corners and the flashing everywhere. What is that right there? That right there, when they put those two pieces together, is a standing seam. So one piece is going to look like that, right there, and the other piece is going to look like that. Standing seam. And realistically, you don't need to seal that, but because usually what they do is they'll seal it like right there around the wall. But you just close that tight, and there's your standing seam. That would be right there. So if you had an possible order of operations for this, it would be flash or counter flash, cap, corner, and then seal it. But again, these order of operations for these types of questions are they're very tricky. So you got to take your time. But you also got to know what they're talking when they start naming stuff like flashing, counter flashing, like getting it. Like again, I have it in my schoolwork here. So again, any good website you can pull that up and have a look at it. But as long as you just memorize that the top is a coping, the bottom is a counter flashing, and what the purpose of that is to keep water out, right? So. Order of operations, let's see. Oh, and we're going to stay, again, eavestrough. Eavestrough is part of roofing and flashings and stuff like that. Again, it's all about keeping water out or protecting buildings from water. So, order of operations for an eavestrough. Pretty straightforward. You're going to measure it. Yeah. Measure, cut, notch, bend. Pretty straightforward. If there's anything else to add in there, it shouldn't be that difficult, right? If they throw something else like look for obstructions, well, that'd probably be it up there. If you had to put the silicone, because again, there's always parts of eavestrough that you can seal. So where would that be? That would be at the end. But pretty straightforward for that one. But let's stick with eavestrough. So eavestrough, how often should you fasten it? So let's draw what the profile looks like. So there's your profile of a roof. So underneath, that's your soffit. This part right here, the board. The fascia board. What do you nail the eavestrough to or screw it to? The fascia board. How often should that eavestrough be nailed to that fascia board? Maximum every 36 inches or every 3 feet. What should the slope of that be? So your slope of an eavestrough is less than, like when we talk about boiler breaching, we always say 1/4 inch per foot. This one is 1 inch per 16 feet. So, because again, if you had 1/4 inch per foot slope on an eavestrough, it would look awful. it would be, the slope of that would look terrible on your garage. At least that way you've got a little bit of slope right there. And for eavestrough, not a whole lot pops up, but you should know little basic ones like that. So now, sticking with again roofing, if you guys recognize this, there's your cone, right? So that part of your cone is the apron. Minimum distance for aprons. Now, again, they say those should, anything with flashings, and the width of flashings you always go with 4 inches. Now, I have seen aprons, like if this was like a 3-inch cone, that apron wouldn't be 4 inches wide all around. It would be close to it, but the number that I've been taught by different schools and stuff like that, and I see it as a general rule, if they're asking you the width of flashings, or if you have a step flashing or anything like that, the height of it, 4 inches is always a good number to go with, because there's a lot of different flashing widths that they could ask you about, but I've always been taught 4 inches to go with. So now we're going to get into, we'll talk about this in metallurgy, but we'll talk about it in roofing as well, because it's a possible question that can pop up, is if you're doing a copper roof and it's got to be laid down on to say galvanized, or it's touching galvanized, like you have 2 different metal products, what do? You have to separate them. Why? Because 2 different metals create galvanic reaction and or what is known as electrolysis, especially when it gets wet or damp and it just eats up the metal. So you separate with, the real cheapskates separate with cardboard. Roofing felt is what you should be separating. If you want to spend a little bit more money, neoprene, right? So now we're going to talk about when you get into metals, expansion and contraction. So considering expansion and contraction, what is the best seam to use for a roof? Now, of course, we're talking about commercial roofs, right? And that's called a batten seam. So, and again, if I'm going over it, there's a reason I'm going over it. What does a batten seam look like? Okay, so imagine like, that's supposed to be a piece of wood. Even though some people don't use it. There's the basic idea of a batten seam. Now, of course, there's going to be a little, piece in there to hold that. But basically, that's the idea. So that there's room for the big piece of, like, again, big commercial roofs, commercial plazas, you'll see this all the time. And that's it. Now, if you're laying this roof down, what is the first thing you're going to put down? Cleats. How are you going to make sure those cleats are straight? Chalk line. And as I say, if I'm telling you these, it's for a good reason. Write it down and memorize it. Okay, another good question. How do you permanently seal a copper roof? And again, I've talked to guys and they're like, oh yeah, you just nail it down, put a pin in it and put some caulking on it. Well, how do we permanently seal copper pipe? We solder it. It'll never, if you solder copper, it'll be like that forever, right? So that's the idea. You don't seal it with tar or silicone. If you're roofing, you seal it with by soldering, right? And while we're on soldering, galvanized eavestrough. I know it's all aluminum now, but back in the day, and it still is in some places, you still get galvanized eavestrough. What flux would you use to solder that end cap on? Muriatic acid. Now, of course, some people say, oh no, what about zinc chloride? Well, zinc chloride is used for a little bit heavier, heavier situations with heavier metals, like say in black iron, or very old and rusty and really bad shape galvanized. You could use zinc. Might have to use zinc chloride, but generally it's muriatic acid. Okay. Oh, and now here we go with flashings. So I'm gonna. This is a question I'm gonna get into that has a lot of people saying different answers. So say that was the flashing on the side of your house or your garage or a commercial building, and it had those 2 V-bends in it. Now, most schools work will say it's there for strength, which theoretically, of course, anything you put in is strength. Some people say, no, it's not strength, it's a stiffener. Well, strength and a stiffener, that's the same thing, but it could all be in the wording on the CFQ. Another thing is, if you also talk to guys who are roofers, they say that these V-bends are for expansion and contraction. Now, I can tell you right now, this is a good, well, it's what I call one of the great debates among sheet metal teachers. Because a lot of them are saying, no, it's for strength. And roofers are saying, no, it's for expansion and contraction. So when you're looking at the answer column, if you see expansion and contraction there, and you don't see strength, well, good for you. But if you see strength and expansion and contraction, well, you got a 50-50. So depends on what school you go to, will they say what the answer for that is. Because again, and my theory behind that, I like expansion and contraction because that is the bead that we put on ductwork. You want strength, you put a bead on it. You put a V-bend on it, it's for expansion and contraction, in my eye. Now, other teachers disagree with that, but you know, there's always got to be a debate somewhere, right? You got to argue about something. Okay, so for outdoors, for if you're going to seal something and you have to paint it, so what is the best kind of there? I personally didn't know. I saw this in my schoolwork, but basically, latex caulking or butyl. That was in one of my school notes. If it needs to be painted, if you're not painting it, it doesn't matter. But if it needs to be painted, right? Latex or butyl, which I've never heard of. Okay, I went over that. I went over that. Oh wow, I went over all that. Good. A side profile of a coping. So if I was talking about a coping and I looked at a side profile, could look like that, and like that. And again, you could get a order of operations for bends on this one too. So again, which ones are you going to bend first? You're going to bend those ones first, right? And then again, which ones will be the hardest ones to bend? Personally, I think these ones in here would be the hardest ones to bend, and then you can bend these ones last because they're not the tightest bends. But again, you got to take your time, read the question, and go over it slowly. But always remember, smallest to largest bends for order of operations. And when they're talking about bending this, because again, they talk about order of operations, and they love to play games with you on the CFQ where they'll show a picture of this halfway through its bend, and then they'll go, okay, is this going to be bend up or bend down? So it's always important that you know how a profile looks before it's bent, and how it's bent too, because they love throwing those tricky questions at you, and if you can't think for yourself on it, you're gonna land yourself in a bit of trouble on that. But that's something to keep your mind open to. And what else do I got on flashings here? There's always something. Oh, okay. Now again, back to the roof. So basic things like your gooseneck. What's that angle? 135 degrees. If you can't remember 135 degrees for a gooseneck, well, you have issues. But it's a 40, it's a 45 and a 90, basically, right? So basically, there's your 90 and there's your 45. Your throat should be half. It should be half the width of duct. How high should this be off? It should be 18 inches for snow. So if you're not in a snow area that gets a lot of snow, you shouldn't have to worry about it. And there's really not much that can be, oh, yes, prevailing winds. And if you guys, I asked, a great answer I had for this was, where would you point that? And one guy said, oh, he just looks down and looks at the other roofs, sees where everybody else is pointing or something. And you know what? It's a good general rule. If you don't know what the prevailing wind is. So where we are, and I think everywhere in North America, prevailing winds come from the west or west-northwest. So this should always be pointed generally east. Generally, right? You can argue about it, but as long as it's pointed eastwardly or, again, away from prevailing winds, right? So that's pretty straightforward. So we're going to stay with stuff coming out of the roof, which, again, A vent, B vent, C vent, or even Z vent. I don't know if, for the guys, I don't know if you've seen it before, but when you see the plumbers hooking up their boilers and they got that really nice fancy shiny stuff that's basically stainless steel, it's now called Z vent. Most of us are used to A, B, and C vent. And just for a little review, C vent is just straight pipe. So, or it's usually heavier gauge pipe, but it's just a single walled pipe, heavy gauge. How many screws? Okay, there we go. Have a little technical difficulties. So back to this C vent. So C vent, and of course A and B. C vent, single walled, 3 screws minimum, right? So 3 screws, pretty straightforward, right? A and B vent. A and B vent. One it's double walled. The one has insulation in it, and the other one is just an air pocket between the double wall. How many screws minimum when putting this together? 0 for either. They don't put screws in them because you might accidentally puncture the wall. They lock together. Well, how do you make sure they don't unlock? Well, some guys will put a little screw in the thread of it, but you shouldn't. Basically, when you put your hangers on it with a bolted hanger, that's going to hold it, but no screws, because just in case you puncture it. And guess what? Then you have carbon monoxide leaking all over the place. Very good. Pretty straightforward, but we'll get into the generalization of this in a second. All right. Okay. Sorry about that little glitch. Back to A, B, and C vent. Did I just talk about that? Yes. Snapping it together, 3 screws or no screws. Okay, but why are we talking about... Oh, okay, here we go. Just gotta get back to my notes. So, back to the roof again. Okay, so there's a roof line. We'll draw a little... yoink. A little B vent coming out of the roof. Pretty straightforward. How high should that... And again, these are general rules. Like people can pull out numbers out of this gas code or this book or that. General rule, 3 feet. And where do we get that general rule from? Is this rule. 10, 3, 2. And of course, I even get people arguing with me about that. Oh, that 10, 3, 2 rule doesn't work anymore. Well, as far as I'm concerned, it works for the C of Q, and that's all that matters. So, what does the 10-3-2 rule mean? Well, first let me draw, let's pretend that's a parapet wall, or just an elevation change. So, if you're within 10 feet of that, so let's say from here to here is 5 feet. Well, you're within 5 feet. So that should already be 3 feet above the roof. That's where the 3 comes in. It's always 3 feet above the roof. But if you're within 10 feet of that parapet wall, you should be 2 feet above it. So if this parapet wall is 4 feet high, this B vent should be 2 feet above it. so that, you know, gases don't collect in that corner. I don't know how that's going to kill people and why that's a rule, but obviously somebody, usually these rules that they put in place, somebody died and it was an unforeseen accident, but because of that, stuff collected in an area and somebody died from it. And so that's why these rules. Same with the green book, the safety book. That thing's going to, as more people get killed and are maimed on job sites, that book will just keep getting fatter. So here you go again. So 10 feet away from that wall. So let's change this. We're 15 feet away from that wall. How high should that be off the roof? 3 feet. It's always 3 feet. So let's go back again. If you're only 5 feet away from that parapet wall and it's 4 feet high, this should be 6 feet instead of 3. Now 6. Or if that little parapet wall is only 2 feet high, then this only needs to be 4 feet up. Right? So any gas venting, whether it's A, B, or C venting, or from whatever gas appliance, is that. So 10, 3, 2. 10 feet away from an upper elevation change or a parapet wall, always 3 feet off the roof, and then if you're within that 10 feet, 2 feet above that elevation change. 10, 3, 2. Remember that. It's going to get you a mark. Okay. I guess I should, well, let's go back to that. Let's go back to the rain cap. I probably shouldn't call it a China cap because that's racist or something like that. Everything you talk about now, if it's got a name, it seems to be racist. But okay, I guess if somebody's feeling hurt by that, we should stop doing it. Right? So, what can we talk about that rain cap? Well, I can tell you this much. If this pipe, A, B, or C vent coming out, or even Z vent, is coming out of the roof, let's say it's 10 inches in diameter, 10 inches round. That means the width of that rain cap is 2 times the diameter. So let's even put 2 times diameter, so it should be 20 inches from there to there. How high should that rain cap be off there so the fumes can come out? Half diameter. So if in this instance 10 inches, that's going to be 5 inches. And the only other thing that's going to come into play here is the angle right there of that China, the rain cap is always 30 degrees. Other than that, you're not going to see any questions that are going to pop up on you. So I'm going to stop there. And that's pretty well it. There's a couple other, there's another one. If I can take through my notes. I have so many notes from so many schools here. Possible questions of, let me see, just give me 2 seconds. There we go. Sequence for flashing a chimney. Now, when they say a chimney, I don't think they're talking about the one I talked about earlier with the cricket. Because this one is flash, collar, cap, seal. So flash, collar, collar. So it's something round. So that's pretty straightforward. Look at me doing some thinking. So, rain cap. So flash, collar. So there's always your flashing down here, and then there's your rain collar, like that, or rain collar, or weather cap. There's lots of names for it, right? But as long as you slide that down, have it bolted on there, and again, you shouldn't be screwing it, because if that's A vent or B vent, you screw into it, you're piercing it again, right? The only thing you could do is put your seal on there. So flash collar, that would be your cap, and then seal it, right? But that, like ones like that shouldn't be too difficult. It should be really straightforward for most guys, because we've all done something like that somewhere in our lives, right? Okay. All right. Okay. Again, flashings. They can be tricky questions, especially for guys that don't do flashings. I'm one of them. So again, I'm trying to pull these kinds of questions from material that I'm getting and or talking to actual roofers that do that stuff. So I'm going to go into, because there's a lot of little areas. Like again, I talked about plasma in this lesson, and it's only so many questions. Actually, I was just looking through my notes and I saw another plasma question, but it can be lumped into another division as well. So here's another division. Another little piece of info is spacing. Now, you could get, or you might not get, like a question on spacing, but there are different kinds of questions with spacing that you could get. So again, it'll only take a couple minutes to go over, but we're going to go over. So there's ones where you have spacing of a straight line, like a linear, something linear, and then they also have spacing of things that are round. So we're going to start with the straight line spacing, because it's pretty straightforward. So what we're going to do is we're going to pretend that's boiler breaching, right? Does it matter that it's boiler breaching? Not whatsoever. So here's a possible question. You're going to put 6 hangers on 20 feet of boiler breaching, basically from end to end. Now you're going to put 6 hangers on that. Now I don't think we've gone over this already, because we're pretty early in the lesson. So because once I get farther on into lessons, I may have gone over stuff that I'm repeating, and hopefully you don't mind. I'll apologize now. So you have 6 hangers. The first 2 hangers from each end are 2 inches in. Right? And again, they're not going to draw this. You're going to have to visualize this yourself. And I always tell guys, they give you paper when you write the CFQ, use it. Draw stuff out. I'm going to also be telling you to draw your working triangles, but that's down a couple lessons down the road when we start getting into the more difficult stuff. But if you need to visualize something that they're trying to explain to you, and especially if it's got measurements, draw it out. It can only help. It's not going to hurt. You know, if you use up that whole page, flip it over. Use the next page. If it's done, go up and ask for more paper. Like don't be intimidated. Especially don't be intimidated when you're writing your exam, because they love making you feel intimidated. Don't be. Okay, so 20 inches in, 2 inches in from each end, 6 hangers. So there's 1, 2. Okay, so I'm gonna go 2. Okay, again. So we're visualizing 1, 2, 3, 4, 5, 6 hangers, 20 feet. Let's change this to inches, because this is in inches. It'll just be easier. 20 feet, of course, times 12 will give us inches. That is now 240 inches. Okay, so from let's go up here. From here to here is now 236 because 2 inches in, 2 inches in. Now we're going to figure out what the spacing is. So 1, 2, 3, 4, 5. Oh, wait a minute. Huh. There's 6 hangers. Why are there only 5 spaces? Well, that's why we draw that, because I don't know how many people would have divided that by 6. I've even heard guys pull number 4 out of their ass. And I don't know where they're coming up with these numbers, but when you draw that out, you can see 6 hangers, 1, 2, 3, 4, 5 spaces. 236 divided by 5. And of course, I don't have my calculator with me. Okay, calculator. 236 divided by 5, pretty straightforward. Equals 47.2 inches between hangers. Oh, for a little practice, 0.2. That's probably not going to be the answer in the answer column of A, B, C, and D. It's going to be 47 and a quarter, or 47 and 3/16, or 47, or actually, I shouldn't even say that, because the answer column, they'll do it, the other one, they'll divide it by 6. So they'll go 236 divided by 6 equals 39.3. So a couple of the answers will be 39.3. We'll make this one 39.3. Again, what's 0.3? Or what's 0.2? I don't know if you guys remember that. Let's do a review. 0.2 times 16. Why 16? 1/16 of an inch. You only get it 1 or 2 times that you'll need to do this on a C of Q, but 0.2 times 16 equals 3.2. Get rid of the 0.2, round it down to 3. 0.2 is 3/16. And what was my other answer over here? It was 0.3. So 0.3 times 16 equals 4.8. So we'll round it up to 5. 0.3 is 5/16. Again, you guys should always practice, unless you're like really good at that, bang, bang. But how do you change a decimal to a fraction? Multiply it by 16, as in 1/16 of an inch, right? And if you're not good at that, practice, please. So again, spacing question. So again, I remember when I was back in trade school, like my last part of trade school, we reviewed this for obvious reasons. They give you, you're gonna rivet 2 pieces of metal together, like that, with 17 rivets. You don't need to know any of the other special stuff for rivets, like 1.5 times or 2 times. Although, hey, while we're here, the distance from the edge of metal to your rivet is 2 times the diameter of the rivet. How far should that rivet protrude through the metal? 1.5 times the diameter. And pretty straightforward. Again, you should be good at multiplying your fractions. So, because again, the diameter of your rivet is probably going to be 1/8 of an inch. But let's get back to this. So 17 rivets. So if you remember last time, we had 6 hangers. How many spaces between 6 hangers? 1 less, 5. So how many spaces between 17 rivets? 16 spaces. Oh, is that important? Obviously, we just figured that out. So we'll pretend that's 17, but again, 2 inches in, 2 inches in. And we'll say that, we'll just pick a number, we'll say that that's 4 feet, or 48 inches. Minus 2 and 2, so now it's actually 44 inches from there to there. 44 inches divided by 16 spaces. 44 divided by 16 equals 2.75. So the space between each one is 2.75. And, well, 2.75 is pretty easy to figure out. So you know that's 3/4 of an inch. We didn't have to do any math there. Okay, so that one, again, pretty straightforward. Let's get that off the board. And hopefully, you know, it's pretty straightforward soaking that in. Now, let's go to the round one. So, if this was a question, it could be, it won't be, again, none of these are drawn out for you. They're in words. So, the next one, they're going to tell you, you have a 12-inch pipe. You have a 1.5-inch flange. You have 8 bolts. What is the spacing between those bolt centers? So, where do we start? Oh, we're going to draw a picture. So let's start. There's the 12-inch pipe. Oh, a flange. Not an inside flange, I can guarantee you that. 8 bolts. Okay. And of course, it's between bolt centers. That's why I'm doing like a little X. So again, to help you envision it. Excuse me. Now, between bolt centers, so there's that bolt center right there. So I'm going to draw a line there. And there's that bolt center there. Right, just so you can see where that one's coming from. Right, not to make a mess of it. Alright, so just like an architectural drawing or a shop drawing. So, if we know from there to there is 12, flange is 1.5. What's the distance from there to there? 13.5 inches. So, how are we going to figure out the spacing around here? Oh, circle, pi. Pi times diameter. I'm just going to write 3.14. Some guys might add an extra. For most questions, I just go 2 points, 2 decimal points. Some guys might go farther, but I get away usually with just going 2. So 13.5 times 3.14. Now, there's 8 bolts. Yeah. How many spaces with 8 bolts? 1, 2, 3, 4, 5, 6, 7, 8. So that's where they get kind of tricky. If it's in a straight line, there's always one less. If there's whatever it's bolts, screws, rivets, it's always one less if it's a straight line. If it's in a circle, because it comes back to itself, if there's 8 bolts, there's 8 spaces. So take that and divide that by 8 equals, and we'll go through it just for 13.5. Looks good on the calculator. Times 3.14, yep, equals 42.39 divided by 8 equals 5.2. Well, actually it's 5.298. So let's have fun and just round it up. Is 5.3 going to be in the answer column? It might, but what if it's not? What if it's a fraction? Now, we just did that as a fraction, but let's practice it. How do we turn 0.3 into a fraction? Multiply it by 16. Why 16? 1/16 of an inch. Not, well, you can go by eighths, but or by quarters, like 4, but the smart move is by 16. Just get into that habit, and it will benefit you a lot. So 0.3 times 16 equals 4.8. Round it up to 5. 5/16. And that, ladies and gentlemen, was your spacing lesson, which only took 10 minutes. Just eating up your life. But it's important. You know what? You learn this, you write your CFQ, you pass, and guess what? You can take all these books and have a bonfire, have all your friends and family over, burn all this shit, have a beer, and never look back. Although I always say to my guys, don't burn it. Maybe you can help somebody in the future. Maybe one of your buddies is going to be hurting trying to pass the CFQ, and maybe you can do your part and help somebody in your community, the sheet metal community. All right, beautiful. Okay, so I've taken some time so you don't have to sit and watch me do this, but I drew up a chart. This is one of those charts where you're looking for information. You take 2 or 3 different things, line them up, and pull out information to figure out, well, this is going to be a load rating. And this is the kind of possible thing that could come up on the CFQ. So we should learn how to do ratings like this. So the question being is, and what I'm going to do, because this is my fun part, is this is like a test. I'm going to see, okay, are these guys clicking in? Although you're not in front of me, you're sitting wherever. I'm going to show you guys what you got to do. I'm going to stop. I'm going to basically just stop it and then basically turn it back on, and then you guys can have all the time in the world. You can have 10 days or 10 minutes or 10 seconds to figure out this question. So let's start with shear strength and tensile strength. You guys, you've heard it before. What is it? So shear strength is when you put a hanger like a nail in, or an anchor, like a sleeve anchor that you're gonna put a thread around. You're gonna put like an anchor like that into a wall. So that's shear strength. So basically it's got to shear off to actually fail. Then there's tensile strength, and that's when you put it up into the slab. And one way, one teacher reminded us how to remember that was the T for tensile strength is like that. So it reminds you of, it goes up into a slab of concrete, as opposed to that is shear strength, tensile strength. Okay, so here we go. Chart. Oh, there's your chart. There's the question. You're going to hang an 8,000 pound sign. Ooh, 8,000 pounds, nice. 8,000 pound sign on a wall. Ding, 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 clue. Wall. We just went over that. Rewind this if you need to. Sherlock Holmes this thing. Listen to what the clues are saying. 8,000 pound sign on a wall using 3/8 bolts in 3,000 PSI concrete. And how many bolts would you need if the safety limit was plus 25%? Now, there's a little mumbo jumbo in there, but realistically, if you just take a deep breath, relax, and enjoy the question. Okay, all right, so now, first question is, how many hours or minutes did you guys take to do that? Or did you even figure it out? Well, it really doesn't matter because we're going to do it together, right? So, all right, so 8,000 pound sign. Okay, straightforward. On a wall. So we talked about that before. You either have it on a wall, you have tensile and shear strength. Which is which? Tensile is on the slab going up. Shear strength is going into the wall. So obviously wall is shear strength. So we're in this category here, right? I could have separated that a little bit better, but I think they're not going to make it that easy for you. When they give you the charts like this, they're not going to spoon feed it to you like, oh, here, go right here and look right here because you're an 8-year-old kid. Although I've seen 8-year-old kids do better. No, I shouldn't even say that. That's terrible. But yeah, you get where my drift is, right? Using 3/8 bolts. Oh, shear strength, 3/8 bolts. 3,000 psi concrete. Oh, wait a minute. So there's 3,000 psi. There's 3, and like, oh, look at that. 225 pounds. Yeah, I think so. So, then what are we going to do with that? So, 8,000 pounds sign. Well, let's see if I got any room left on this board here. There's my hand scribbling. Yeah. So we're going to take 8,000 pounds and we're going to divide it by 225. Can we still see that on the screen? Perfect. Beautiful. Gentlemen, ladies, 8,000 pounds divided by 225 equals 35.55. Now, just the extra little curveball I threw in the side, trying to get by you. Curveball, fastball, slider. Plus, a safety limit. Oh, is that a special formula? I don't think so. A safety limit of plus 25%. I think it's self-explanatory. If it's not, well, I'm sure that your boss is going to have a broom and a dustpan. You can sweep up the job site, right? Or duct seal for the rest of the job. So, add 25. Oh, that's right. We went over this. Multiply by 0.25%. Multiply by 0.25. So, 35, I'm still up on my calculator, times 0.25 equals 8.8. So, wow, I'm going to try something else. I'm going to go like this. 8,000, make sure it's on my calculator, divided by 225 equals 35.5. But instead of multiplying by 0.25, I'm going to multiply it by 1.25. So it combines everything. Multiply it by 1.25. See if that works. Oh, yes. 44.44. So again, right now we got 44.44. Now, if we were to round that up or down, we would round that down. But let's think about that for a second. If you round that down, our safety limit and the load rating is 44. What's the smarter thing to do? I personally think round it up. It's only like just over half of, like obviously mathematically you would round down, but realistically you would round up because it's a C of Q and it's all about spending money. That's what you need to remember. So if that number was on the C of Q, 44.44, I would use it. If 44 was on, it would say the A, and say 45 was B. Ooh, that's a tricky one, but me personally, I would take B. Because you're lowering the load rating. By taking 44, you're lowering the load rating that's been specified. By going up to 45, you're there for sure. So that was, I don't mean to drag on so long. I'm looking at the time, that took 5 minutes. But if you're having trouble like reading stuff like that, or reading shop drawings, and stuff like that, you know what? You better start reading them and looking them over, because that's your job as a sheet metal worker. Hey, putting up 2 hangers and putting up 10 feet of duct, that's part of your job, but there's a lot more to it. I was just saying this to somebody today, actually. I was tutoring a gentleman this morning. There used to be commercials for the U.S. Army. I think it was U.S. Army. Said, be all you can be. Well, you know what? Be all you can be as a sheet metal worker. Again, I'm not here to make you a better sheet metal worker. I'm here to help you pass the CFQ. But there's nothing wrong with absorbing as much knowledge as you can to solve any problem that might be thrown your way in the future on a job site. So when a problem happens, you're not like, what do we do? Well, let's look at what the problem is. Let's talk with other people. What are the possible solutions? And no, not fist fighting with the plumber is not a possible solution, right? I know most of us think that way, and on most days it's not a bad option. But no, using your brain is the best option possible, and absorbing as much knowledge as you can, even with something as simple as reading a load rating, a load capacity drawing, right? Okay, so I'm not even going to erase that, because this may or may not be the end of lesson 3. It depends when I edit my timing. But I'm also going to go back to, I am putting up, I'm starting spit it out, man, an email address for people to get a hold of me that continue to struggle. Over my 10 years of tutoring people, there's still gentlemen that still can't pass the CFQ, and there's guys that I've helped, again, that have taken refresher courses through certain halls, and because they have obvious learning disabilities, they struggle with passing, but that's okay. They get left behind in class because the teacher has to keep going because there's so much material, and 1 or 2 or maybe more than that get left behind. That's okay. But those are the guys I'm trying to help. So, okay, so back to the part about that. You guys can get hold of me. Again, I've talked about, and I continue to talk about, how many guys I've tried to help in the past. Usually, with a little bit of help, guys will be able to pass. Some guys need a little bit more help, several more hours. But there's always going to be a small handful of gentlemen that just struggle with book work. Hey, and I know these guys. A lot of these guys are great tinners. They can bang tin like nobody's business. But when it comes to opening a book and passing a test, it's a struggle. So again, I'm going to make myself available to guys that are in that boat. Try to do it with just this bit of help. But if not, get a hold of me through the email address, and then we'll figure something out. Whether it's extra notes I send to you, or I don't know, somebody suggested Skype to me, or even just sending messages back through text messages, or even talking on the phone and going over stuff. But hey, if you fail, don't give up. Continue to study. Keep trying, because you're going to pass this and then get the weight of this CFQ off your shoulders. Okay? So I'm going to put it up on the screen, and while I'm waving my finger around like this, make it look like magic. So if anybody wants to get a hold of me, or just, be an asshole, tell me to fuck off or something. I don't know. But we'll see if this is the end again. But if not, lesson 4 is coming up. And again, gentlemen, ladies, I also appreciate your patience with me as a teacher, because I'm not a professional. And thanks for coming back to find me on this YouTube channel.